Okay, welcome back, everyone. I hope everyone had a good weekend. It's time to do our morning algorithms here. So let's get started. We are at week 2, day 1, and we have some new JavaScript inbuilt functions here that we're going to go over. We're going to try to predict here what each of them do. Some of you may know already what these do, and if you do, well, can't help it. We'll find out what these do in just a minute here. So let's go ahead and take these functions and use them here. So we have, let me increase the size. Math.floor. Can anyone tell me what math.floor does?
It rounds down the number.
Okay. What do you mean by that?
So let's say you have 1.8. If I'm not mistaken, it would round it to 1.
1, right. Okay. So it will take the part after the decimal point here, the integer after the decimal point, whatever integers follow, take that number and round it down to the nearest, this would be 1.0 because it's going to the floor. So let's take a look at the documentation here that says math.floor is a static method, always rounds down and returns the largest integer less than or equal to a given number. So for example, 5.95, the output would be 5. 5.05, it'll go down to 5. 5 remains at 5. And negative 5.05 will go down to 6 because it's a negative number. It's not going to go up. It's going to go down to the floor. Okay, so for example, if we run these, you'll see that's the output. 5, 5, 5, and 6. So if we take here, let's see here, let's uncomment these. Let's just console log this var floor. Let's clear my console. And we get 1, as expected. Okay, now, based on what we just learned what floor does, what do you think math.ceil will do?
Round up.
Yep, round that up.
Right. So let's take a look at this. We call this var ceiling, and we make it equal to math.ceil, and then we put math.pi, and this is 3.14 and so on. So let's go see what this does. It'll go up to 4. Okay, and let's go ahead and take a look at an example on the documentation here. Oop, I clicked the wrong tab. Math.ceil, static number always rounds up. So 0.95 will go to 1. 4 remains at 4 because there is no decimal point following it. It's not going to go up or down. It's already at a integer position. Now 7.004, no matter how small the decimal point number is, it's going to go up. So this is going to go to 8, and 7 is going to go to negative 7.004 is going to go to negative 7 because that is going up instead of down. Down would be negative 8. Okay, so this is math.ceiling. And let's go over the third one we have on our list here, math.random. Okay, what does math.random do?
Gives you a random number.
Gives you a random number. Okay. Can we get any more specific?
Between 0 and 1.
Yeah,
gives you a random decimal point number from 0 to 1. So it's a large decimal point number. Okay, so let's look at that one for a second here. Math.random. It's a static method that returns a floating point pseudo-random number that's greater than or equal to 0 and less than 1, with approximately uniform distribution over that range, which you can then scale to your desired range. Okay, so after we get that random number, as you can see here, it'll always have this large decimal number. You can then manipulate that math.random. So you can use math.floor on it, math.ceiling. And that's the great thing about this math.random. Okay, now let's get a status check. Do we all understand how math.random, math.floor, and math.ceiling works? Okay, great. Very simple concepts today. So what we're going to do today is we're going to break out into groups, and we're going to do 2 algorithms in these groups. We're going to do dice roller and consult the oracle. So the first one, dice roller, what we're going to do is create a function that can roll a dice between 1 and 6. And then we're going to console log what the player rolled, as if a player is playing with dice. Okay. So we gave you the function and the code goes in here. All right. And the next one will be consult the oracle. So this one, the instructions are: using the following array, write a function that will answer all of your questions by randomly choosing a response. So we give you a array here of strings. And in these strings, we have multiple answers. Better not tell you now, cannot predict now, concentrate and ask again. Lots of different answers. So how can we create a function that every time we invoke the function, it will give us one of these answers? So let's find out how to do this in our groups today. We'll regroup, share our answers. There's more than one way to do both of these functions here. So let's go ahead and do that and see what we find. Anyone have any questions? Okay, great. All right, let's go ahead and create the breakout rooms. I'll go ahead and do that now. Give me a moment here. All right, go ahead and present for the dice roll, please.
Okay. So this is one where, so we kind of changed that top part to make it seal math random times 6. And we made that roll. So that basically would mean that the variable roll is going to be a random number between 1 and 6. And we got that by the seal. And then that put that into the roll return. And then now every time we run it, we get a random number from 1 to 6.
Okay. And why did you use math.seal instead of floor there?
Well, as you showed us during our little time there, when we were looking to go for an index from like 0 to something, floor seemed to be the best option because you could multiply it by the length of the contents of an array. But if you're trying to find whole numbers between 1 and something, then it's best to use seal, because then you can go from 1 to however long the numbers that you need. And then in this case it was 6 because we had a 6-sided die.
Right. So if you make floor instead of seal, floor will go to 0, and 0 is not a possibility that we want, right? We want it to go from 1 to something, so it will always go up to 1 if we use seal, and then you just multiply that by 6 randomly. It'll give 1 through 6. So very nice. You guys changed the code though, so still credit though. You guys did well. All right. Would anyone like to present for Life's answers?
We could do that.
Okay.
You want me to share my screen?
Yes, please.
Okay. All right. So for this, there's two ways we could do it. So we have the array. We created this function, random answer. We call the function here, we invoke it right here by creating a new variable or variable oracle. So when we call it, we created a new function inside we created a new variable inside the function, which what it does is that at first it generates a random number and then it multiplies it by the length of the array. So that is from 1 to 20, right? And then we added the math.floor so we can floor it. So what the floor basically does here, like how here it goes from 1 to 20. It could be the maximum number it could be is 19.99999. Okay. So what the math.floor does, it brings it down to 19. And that's what we need, because we need it from 0 to 19, like on indexes wise.
Okay.
So it generates the random number. It generates the answer. We return the answer into the function. So the answer to the function is whatever we got here, and then we cancel log life answers at this number, at the oracle that we got, at the number that we got from the oracle, which would be from 0 to 19.
Okay.
So
let's check that really quick. I just want to give an example.
Okay, let me just clear this. So it's so
Nice. Okay, so it works fine. And continue please for line 42.
for 42, so if you do math ceiling, you would want to subtract 1 from the length, because what it does, let's say if it's 19.5, it's gonna seal it to 20, and 20 is not a valid answer. So like if you can't, if you leave it without subtracting 1 and you run it, you're gonna get for the index 20, you're gonna get an undefined answer.
Okay, it's giving let's see.
Oh, okay. So if we leave it without subtracting the 1 and we use the math ceiling and you run it, all right, just keep waiting for it. One of the answers is going to be undefined. Here it is.
Right, because it's looking for an integer number that's outside of the array.
Correct.
Right. Okay.
So you just subtract 1, or you use the math.floor.
Right. Okay. So there's more than one way to do this. Well done, guys. Does anyone have any questions about this? It's okay to ask. If not, I'm assuming we're all 10s here. So can we get a status check on how we're doing with this answer? Okay. We're in a good range here. So let's go ahead and wrap up our algos for the day. And we're going to get to more JavaScript when we return. So let's go ahead and return 10 after the hour. Okay. Thank you guys very much. We'll see you soon.